So, hello everyone, and welcome to the second installment in this series. That is part of the minor clinical research principles and practice. In the previous video, we covered a little bit of the data editing, about creating new variables and calculating times in SPSS. Now that we've done our calculations, we're going to go into the univariate analysis for a bit. As in the previous installment, you can find the script on Blackboard. It's annotated so that you can excuse me, so that you can easily go through it yourself. And just as a pointer, make sure that you always annotate your scripts, particularly data analysis and in the data editing, so you know, for instance, a few months later that what's going on. So you can do this by typing a star and closing off with a point, just to make sure that SPSS understands this is a comment and this is not code that should be run. You can run it, but SPSS will not do anything with it. So before we go into our analysis, we always want to plot our data first, and we do this with the graphs builder. I use the legacy dialogues, which is basically saying this is the old SPSS, but you can also use a chart builder if you're more into that. As I use the old SPSS, I'm going to use the legacy dialogues. And first, I'm going to do a bar chart where I'm going to do a simple bar summarizing groups of cases by, for instance, I want to represent the number of, or the percentage of men and I'll just show these. And here we've got a bar chart for the percentage of men and women. One is males, so approximately 65% of the population are males, and 35% of the population are females. If I now want to show also the outcome, I go to the bar chart and use the clustered. This basically means that across another variable, I create these two bars. So here again we've got our category axis, which is gender, and I'm going to define that by outcome. Right click to see the variable names, define clusters by outcome, and I want the percentage of cases again. Usually I press paste, but I've already done that, so I'm going to press OK. And here you can see here's the legend for our outcome variable, and here we've got males and females. And we see that the outcome is approximately evenly distributed between males and females. Here you also see the translation that SPSS has done, and you can do this also by typing all directly into the syntax window. Now you saw in the previous output window that we hadn't created valuable labels, so I'm creating them over here just by typing value labels, and then the variable name, the value, and the label that's between quotation marks. Okay, done this, and now I'm going to show you the nice thing about using the syntax. I can basically, if you've pasted to syntax, you can basically rerun the analysis and get the same figure without having to click through the entire menu again. And now we can more easily interpret it. So gender 1 is male, 0 is female, so blues are females, greens are males, and here we've got the value labels for outcome. So next, we want to do some analyses on gender by outcome and see if there are similarities, dissimilarities in terms of outcome between males and females. And to do that, we go to Analyze. We're going to create cross tables, which are basically the way that you want to analyze frequencies. And in the rows, we're going to put the gender, and in the columns, we're going to put our outcome. We want to do some statistics, and in this case, basically the chi-square statistic. And let's see, we're gonna do percentages by the rows. And paste this to the syntax window. So here in the first table you see the case processing summary, and this is basically saying I'm including all cases and I don't have any missings, and this is where it's really about. This is our cross tab. So here we see the column for the people who did have the outcome, and here who did not have the outcome. In the top row are the females, and the bottom row are the males. And we can see that 30% of the females had the outcome, and 0.7% of the males had the outcome. So this is important when considering your percentages. The row percentage in this case are the more easy to interpret number. And if we go to the chi-square test, we take a look at the top one, the Pearson Chi-Square, which is basically the one that you always use. You can use the Fisher's exact if you have very low numbers in your cell. And then the Pearson Chi-Square, this is a p-value of 0.45, which is indicating that there is no statistically significant difference between males and females in terms of reaching the outcome, which you can also really observe, which we kind of observed already through looking at the percentages. So, for frequencies, we use the cross tabs. Okay, next we're going to look at our continuous variables. Again, we go to descriptive statistics, and this kind of time we go to explore. In our dependent list, we put all our continuous outcomes. In the factor list, the dominant serum creatinine. We're not going to do any stem and leaf plots. We only going to do the box plots. And we'll look at the descriptives. Displaying only the plots. Push OK. This will take some time. And here we see the box plots for all of our continuous variables, where here we see the censored, and here the people with outcome. These lines signify the median, the 75th and 95th percentile, and here the 25th and the 5th percentile. And these rounds, these open circles, are outlying values. We see that there's some difference in the systolic blood pressure between people who did and did not have the outcome, but not in diastolic blood pressure. And going over these plots, we can get an indication of where our values are skewed, for instance, like in proteinuria, where we see a clear right tailing, and also where there's differences in between the medians. Here again we see a slight difference, for instance, in hemoglobin, and we continue down and just eyeball whether there may be a difference. So next, we've eyeballed the differences, but that doesn't really make it true, so we're going to do some statistics. In this case, we're going to compare the means, and we'll do the independent samples t-test, with the grouping variable being the outcome, and people who did have the outcome are independent of people who did not have the outcome. So basically, we add a 1 and a 0 here. So basically what this means is that you're comparing two different populations. In this case, people who did have the outcome versus those who did not have the outcome. And we're just going to enter all the variables that we previously looked at. 95% confidence interval is okay, and we'll just paste this and run. And here we see a large table with all our results, each row indicating the variable, and here we can see the difference in means. Basically, I always look at the top the top row, because if this equal variances assumption doesn't hold, you cannot use a t-test basically. And this test is more sensitive to population size, to sample size, than it is to anything else. So it's not very informative. So here we see the difference in means between people who did and did not have the outcome. People who did have the outcome had a 8.2 millimeters squared mercury higher systolic blood pressure baseline, and this with a confidence 95% confidence ranging from 5.2 to 11.2, and this is clearly statistically significant. So the difference systolic blood pressure really wasn't that big, and it's also not statistically significant. And we go down through the results and have a look at it like this. Now here we have a t-test for proteinuria, for instance. However, if we recall, proteinuria was a skewed variable, so we can't actually have a meaningful inference from a mean difference of 0.9, because the mean itself is not very meaningful. So instead of using a t-test, we'll use a non-parametric test for proteinuria. Again, we do the independent samples. Compare medians across groups. We'll use our outcome as the grouping variable, and then use, for instance, proteinuria, but also creatinine, which is also skewed, and see. We'll click paste again, run it from the syntax window, and here we have the test for the difference in medians. Now, if we want to look at the actual difference in medians, we need to examine these variables a little bit more in detail, and we can do this like this. We go to the data, and we'll split the file by outcome, compare groups, paste. See here, we sort cases and we split them layered by outcome. I've also done this up here, and we run the frequencies, which we could find under analyze over here, but we can also run it from here. And here we see the medians for people who did not have the outcome. Oh, I forgot to run the split file, so I haven't compared anything yet. Now we did run the split file, and we see the difference in medians for instance, proteinuria, which has a median of 0.2 in the censored and 0.5 in the people with the outcome. So there is a difference in medians, and looking at this test statistic, we see that the difference is statistically significant. So with that, we come to the end of this video. If you have any questions, you can post them in the comments below. And next time we'll be going into multivariate regression analysis. So thank you for your attention, and see you next time.